Hi, everybody. Welcome to another Hoss Talks FOSS. I'm here with Guy Harrison from ProvenDB, who just gave a great talk, two great talks actually, at Percona Live on MongoDB performance tuning, as well as on the changing face of databases and the evolution of databases. And so, Guy's written several books about databases over the years, and he's got two books currently authored and out there, and he's working on a third. So, thought it'd be great to sit down and have a chat with him today. So, hi, Guy. How you doing?
Hi, Matt. Hi, everybody. Great to be here. Thanks for having me.
So tell us about the books that you currently have out.
Well, I've got a fair few older books that no one's really interested in anymore. There's a couple on Oracle. My first book was a book on Oracle tuning. This was way before open source databases were a thing, and that was quite popular in the day. We're talking about the 90s here.
I might have read it because I wasn't Oracle DBA back then.
Okay, well, it was. I will modestly say it was quite popular at the time, as there weren't sort of quite as many books in those days as there are now. I wrote the O'Reilly book on MySQL, stored procedure programming, worked with the MySQL team, and that's where I met Peter Zaitsev, if I'm pronouncing that correctly, back in 2003. And I've bumped into him, forever since then, and it's been great to see, his journey. It's been fantastic, right? And then I wrote a few more books on Oracle, and then 2015 I wrote Next Generation Databases, which was my attempt to take everything I'd learned about databases in my role as VP of Engineering at Quest Software, which is a large database tools company, and the emerging sort of trends that we saw in open source cloud, NoSQL, big data, that sort of thing. Most recently, MongoDB performance tuning. The startup I'm with has been working using MongoDB as our backend, and learned a lot about that over the last 5 years. Decided to put that down with my son, actually. So I'm at the sort of like one end of the age spectrum, and he's at the other. So hopefully we balance perspectives between, I've got a lot of long-term experience that sort of might be relevant. He's got sort of like a modern developer's viewpoint. So, and it was great working with him, obviously. And then right now I'm working on CockroachDB, the definitive guide, with two of the guys out of the CockroachDB team.
So Guy, you've seen many different databases over the years, and what's kind of led to this explosion of the number of databases? I mean, we've seen this as well. I know, like, some of the data and some of the things that I've brought up before are, everybody's using many different databases now. They're not just choosing one, but it seems like every month there's a new database just kind of popping up. New technology. It's based on one of the granddaddies. As you mentioned in your talk, it could be Spanner. It could be a document database. It could be something else. But what do you think is causing all this growth?
Well, for a long while, the Oracle and SQL Server and even MySQL to a certain extent had a sort of a stranglehold on the database market. Everyone was using the same model, the relational model, the same language, SQL, and there wasn't much room for sort of innovation around that because businesses just weren't interested in anything else. There were a few object-oriented databases that were sort of like struggling to get attention, and they just couldn't break through. But the cloud and the internet really changed all that. Suddenly we had applications that had to sort of span the globe and be always on. And if there's one thing that the relational database just doesn't do all that well, it's handled downtime in a globally distributed way. So if you can't distribute an Oracle database across every continent of the globe and expect it to stay up if there's any network issues. No one does that. No one even tries. So that was sort of, one of the pressures. And I guess the other was developers used not to be in charge of these decisions. So back when I was a developer, you got no choice and no say whatsoever in the technologies that we used in the application. There'd be some sort of senior architect or something who'd say, we shall use Oracle and we shall use Java. But with open source coming along, developers got they could just pick up a database and just start running with it. They didn't need to sort of sign an invoice or anything like that. And, by the time we're talking about, 2009, 2010, as well as sort of object-oriented programming, still wanting something different, there was also the pressures of continuous integration, wanting sort of like schemaless sort of databases where the schema could be completely defined in the code. So as soon as you checked it into GitHub, you could run a build, deploy, and you didn't have to get a DBA to come along and do an alter table. And so that was another pressure coming along. As well as big data, we had more applications with data that just was too voluminous and unstructured to be handled by these old models. So that sort of broke the back of the relational dominance, and that caused a huge amount of innovation from about 2009 on. And you're right, you think there's a new database every day at the moment, but in 2009, 2010, that was literally true. As soon as it became obvious that you were allowed to create your own database, so many came out. It was kind of bewildering, but I think now we've seen, a certain amount of settling down. I can keep talking if you like, but
I think that, one of the interesting things that you mentioned there was, that shift with the developer focus and the developers kind of being able to start on their own. I mean, I mentioned I was an Oracle DBA back in the day in the early, 2000s, late, or before 2000 in the late 90s. And I remember projects that I wanted to work on. If I wanted to, use an Oracle database as a backend, there just was no way, because the cost of just getting something even small was, improbably high. And so, it became something where you really needed to, have that, alternative. And I think that shift that's happened over the last 10 years to where developers get to choose has caused a couple of interesting, things to happen. Number one, it has really facilitated a lot of growth in the number and types of databases. I know, you've talked a little bit about, the GraphSQL databases for some things. You've talked about, some of the more, Hadoop-like, things for the quote unquote data lakes. You've talked about, some of the document databases, some of the NoSQL databases, some of the relational databases. All these different databases have kind of grown, and developers tend to choose what they're most comfortable with or what they think will fit that particular application. And now you've got all the who used to hold the keys to the kingdom, the infrastructure teams, getting thrown over like, oh, here's a new database you have to support. And I know that I've seen this from a operations perspective, especially from a lot of people that I've talked to. They have no practical experience in, let's say, running MongoDB, and all of a sudden, oh, we developed this application, it's in Mongo, deal with it. It's an interesting space.
Yes, that's very true. And you see, when you're working with companies like MongoDB, you see when they start to make that transition into the operations centers, and when they're suddenly, it's not just about developers, I've also got to sort of provide tools and facilities that make life easier for production DBAs in larger organizations. You see their sort of shift in focus and the things that they're concerned about. And it's part of the growing up for a true open source, well, not open source, whatever, but the life cycle of a modern database is to start with developers and then to have to try and sort of cross that chasm into sort of like large scale production, because these people can still knock back the database. It's all very well for the developers to say, I built this beautiful thing, it's on MongoDB. But if MongoDB falls over every day in production on a sort of global scale, then it doesn't matter. The developer can say what they like. A large organization is going to say, no, rebuild it in something else. We're going to go to Amazon or something. But the other part of that equation is, at the very same time that this is happening, we're seeing databases in the cloud really start to take off. And at that point, you've got this, you guys don't even need to worry about it, because we're not going to go to MongoDB in your data center. We're going to jump to MongoDB Atlas in MongoDB's own cloud. And they'll manage the backups, and they'll manage security and so forth. And this is, smoothing the way, I think, for, it's giving, in my opinion, it's given a really good business model for open source to aspire to. Developers on premise use the open source download, free, go with it, use the cloud maybe. But when it comes to monetizing, we prefer people to come and use our fully managed cloud. And that's how we make our money, with the fully managed cloud implementation of what can still be a sort of like an open source product. We don't need to sort of charge enterprise licenses and all the messiness that happens there, where you're trying to persuade someone to pay you for essentially nothing. You're running it on your own hardware. You've got your own DBAs. What are you paying for when you buy MongoDB Enterprise? Just the ability to ring up every now and again.
No,
So
and I mean,
that's
I think that the cloud model has proven itself out, and it's kind of turned databases into a bit of commodity. The one thing that I've noticed, and I'm curious if you've seen this as well, that as we've made things easier, especially for developers to get started, the barrier to entry has gone down, but also the skill level of those who are, having to interact or solve some of these problems has also kind of decreased. So, when there is that kind of big scale problem, it tends to be a bit more difficult for them to figure out because they don't have that kind of database background. They don't have like maybe the basis to troubleshoot some of the things. And a lot of times from a fully managed perspective, cloud providers tend to be very focused on the operational aspects, like the backups, like upgrades, making sure that you're, patched and things. But from a performance perspective, a lot of it's still on, the developer to take care of their own database and make sure that, it's designed correctly and it's implemented correctly.
Yeah, you're right. Even more so than in the past, where you typically have the developer would hand over the application to a production team. Now the developer in a DevOps model is still pretty much fully responsible for performance in production and needs to have a bigger or a more sophisticated understanding of database performance at scale. This is kind of one of the reasons I wrote the MongoDB book, because, working with a lot of MongoDB developers, it's so easy to pick up and get going, that developers were sort of like, not exactly clueless, but not quite as concerned about or not quite as informed about the fundamentals of performance management for a database as perhaps they were, when Oracle was the only database, where you just knew that you had to know how to tune a SQL query, you had to know how to use explain, you had to have a pretty good grasp of indexing and so forth. That having been said, I've been around, an embarrassing long time. And, a lot of my career has been sort of like picking up after developers who didn't know how to tune their database. So I think that's one thing that never changes.
Yeah, and I think that it is an interesting space, because I think that from a cloud perspective or even like a database perspective, a lot of the challenges that I see with people who have with whether it's any of the cloud providers or any of the databases service, it's because of a misunderstanding more than it is that the technology's bad, and it's that kind of marketing message around, hey, this is fully managed, because people think, oh well, it'll just perform. It'll just scale. It'll just handle everything, and I never need to worry about it. And a lot of people just end up paying a lot more money because they upgrade to the next size, to the next size, to the next size, to try and get better performance, better scale. And so that's why your book on MongoDB performance tuning is very interesting. And Mongo was designed to be easy. It was designed for developers, and it is a beautiful piece of software that really enables developers to move faster, and it speaks more closely to a developer's natural kind of like development process than a relational database does. And so that's why helping them understand that hey, there are some things that you need to worry about is important. Now, in the book, or in your travels, as you've talked about MongoDB and talked about some of the performance issues, are there a couple that you might share that these are common things, like, one or two things that it's like, these things always happen and you should watch out for them? They're common mistakes?
Oh, sure. I mean, they're pretty basic, really. Most developers understand that they need to use an index, but a lot stop when they're just using any index. And if you've got more than one filter condition in a query, you can construct a variety of different indexes to support that. And the difference between just any old index and the best index is typically, several orders of magnitude improvement. So that's one. I think another thing is, as a developer, you really need to know the tools that MongoDB provides for you to track performance. And so, like all databases, there's a profiler that captures slow queries. There's a a command that you can use to see how MongoDB is going to execute. And there's execute the query, and there's sort of system statistics that, in MongoDB's case, generates about 1,000 different metrics. And like, that's hard to know. Of those 1,000 metrics, which are the ones I need to pay attention to? But you need to, if you want to be a professional developer in MongoDB, you should know those three tools. You shouldn't just say that's for someone else, or I don't care, or it all worked well on my laptop. You need to understand how to work with that.
If it wasn't for users, all applications would be fast, I swear.
Yeah, well, sure. Without data in a database, database is usually fast. Like you've seen this, I've seen this a zillion times. It worked fine until you put some data in the table or the collection, and then it started to be slow. And the final thing is, there's a sort of like a systematic way to tune databases, like there is a systematic way to tune the engine of a car. You don't. And that systematic way is to work from the workload first. What am I asking the database to do? I'm asking it to do, too much. Can I make its life easier? Can I make it work smarter with indexes? And then after that, you start looking at memory to avoid I/O. And only when you've done all that do you start doing things like, upgrading the disks or sharding. Those things, those operational things should be done last when you've got the workload right. Because if you do them first and then do the workload second, you might find that, I bought 3 new MongoDB servers to shard everything out, but then I found I added 1 index and I didn't need them. So you always work sort of down from the application into the hardware in that order.
Well, and it's funny because nowadays performance equals dollars more than ever before. Because I mean, back when we did Oracle, you might have to get more memory, you got bigger boxes, but I mean, let's be honest, ordering hardware or a bigger box, that was sometimes a 6 to 12 month procurement process at the best of times. Now, when you're talking about performance, it could be, hey, you click a button and it upgrades to a larger instance in seconds. And, that performance impact, if you develop something and architect it a little wrong, could be massive.
Absolutely. I've had the same experience. You used to have to tune because you had no choice because hardware upgrades were so difficult. Now you can just increase the amount of virtual hardware, very quickly, but it's going to cost real dollars, immediate dollars. And another way, I don't think about this all the time, but just blindly consuming more electricity, it's not really very responsible environmentally, is it either, right? If you're a big organization, you've got money to burn and you sort of like quadruple the amount of electricity your data centers are using, you're not doing anyone a favor, right? You're spending money and you're also sort of like spending resources that we should be conserving. So, everything goes to sort of like make sure the application's efficient. And the application code, not just the database code, the application can cache and can sort of avoid asking the database for things that it already knows and stuff like that. That's been true forever. Most of the fundamentals of database tuning are the same for all the different types of databases, and most of them have been true now for a ridiculously long time. But the cloud does change the dynamics of how you have to pay for your mistakes, I suppose.
So I'm curious because I kind of hold a weird view when it comes to schemaless databases. And I use that term kind of loosely because I don't believe, Mongo, a lot of people say it's schemaless. I don't believe that it really is schemaless because you still have to do schema validation. It's just you have to do it in the application, and it pushes kind of that validation around. And if you don't design what that quote unquote schema looks like, you end up wasting space and could cost performance cycles as well. I'm curious, what do you think of that? Is it really responsible to just kind of throw whatever you want in? Should you really structure your data more?
Yeah, no, it's still got the same. Just because there's no create table statement doesn't mean that you don't have to work out what your collection or document structure is. In MongoDB, we have a chapter on this in the book. Obviously, it's sort of the same in a way. It's got a lot of the same considerations as relational modeling, but and you'll see it in all the MongoDB material on their website. There's a lot of talk about, do I link everything? Do I embed everything? So for instance, the naive model for MongoDB is I just have an object and I just dump it into the database as a JSON document, and it's got repeating groups in it. It's got arrays and arrays of embedded objects. But MongoDB can only have 16 megabytes in that one object. So you can't put, for instance, you can't put every tweet for a user if you're doing some sort of like Twitter-like application. You've got to break it out somehow. But you might have enough room to put every line item for an order. That might always fit in 16 megabytes. If you do things like repeating the name of a product in the embedded document, when you need to change the name of a product or change its price code or anything like that, you're going to have to update it in not one spot, but a zillion different spots, as many documents as there are orders. And all of those trade-offs are just as real today in MongoDB as they were 10 years ago in MySQL. It's just a matter of, what sort of denormalization do we want? We don't sort of have quite so easy joins, so we want to avoid splitting stuff up, but we can't embed everything in the same document. So there's a whole sort of discipline for MongoDB, and it comes down to whether you link documents or embed them or do some sort of hybrid pattern. These things are reasonably well understood now, but again, but you're right in that MongoDB just makes it too easy. The first thing I think of, bang, that's my document, and I'll change it later. But changing it later is still an expensive operation. It still potentially requires you to restructure all the data you've added to the application today.
Yeah, and what's interesting, is not only Mongo has some of these things that originally were designed to be very document oriented, to be very focused on the developer and thinking like a developer, so that kind of schemaless push more validation to the code. But over time, they've started to gradually introduce more relational-like features, or things that would be traditionally in an RDBMS, similar to other databases. Because overall, I've seen this kind of interesting trend as companies mature and they develop these kind of purpose-built databases, whether it's a graph database, whether it's relational, whether it's a data warehouse and analytics system, or a document database. They start to incorporate the ideas from other databases. And you mentioned this in the talk that you gave, on the next generation databases, that Oracle has started to include everything in the kitchen sink in their portfolio of databases. But I'm starting to see, like, Mongo, for instance, they've added transactions. Of course, they want, more SQL-like interface, and they're starting to move more towards that. Same thing with analytics, column stores, introducing this, or relational databases introducing more NoSQL-like, interfaces, JSON, whatnot. Why all of a sudden, we've gone to these different extremes where, this database is just really, really good at doing this one thing. Oh, now we're going to add these 20 different things as a bolt-on after the fact. Any thoughts on why we're seeing that kind of trend evolve?
Well, primarily, these companies are just chasing their customers.
Okay.
And their customers are saying, they're going into deals and they're losing deals because they don't have transactions, or because, someone wants a, advanced feature that they can't support. In MongoDB's case, as we talked about it before, growing up past the developers, MongoDB's done really well in some companies that I wouldn't have thought they would have done so well in, including banks, right? So they've managed to persuade some banks to use them even before they had transactions. But they clearly, banks are going to say, look, I need transactional integrity. I can't handle this idea that, my update may or may not be consistent. So they chase their customers, and their customers say, we want transactions. They say, we want to analyze the data. We want to use Tableau to look at the data in the database. So MongoDB adds a SQL bolt-on. Meanwhile, if you're Postgres or Enterprise DB or your Oracle or your SQL database, you've got developers who are saying, we like working with JSON, we don't want to work with tables. So you sort of increase your JSON support within the database. And now you've got this case where MongoDB is a JSON database with some SQL support, and you've got these SQL databases that have JSON support, and they're strengthening on both sides until they're converging again. It's kind of inevitable, I think, that you don't want to be a niche database forever. It's not the best, it's not the best way to capture market share. I guess the exception is the graph databases that seem to be fairly content to stay in that niche because their model is so different that they feel they can't compete head to head against, general purpose databases, but they feel that they've got the edge in this one case. But we see graph databases graph capabilities being added to other databases who are saying, well, we think we can support that niche as well. Now, whether it works out that way in the long term, I guess we have to wait and see. The graph capabilities in MongoDB and Oracle are pretty weak compared to Neo4j or TigerGraph. And so if you really have a graph workload at the moment, you really do want a specialized graph database. But, who knows where we'll be in 10 years.
So one of the interesting trends that I've seen, and I don't know if you've seen this, a lot of companies, especially the larger companies that have very big workloads, are starting to invest more in designing their own versions of whether it's Postgres, MySQL, other open source databases. They've started to kind of codify that, and this isn't a new trend. It's just I see it accelerating a bit because Google and Facebook. I mean, Facebook obviously has created many different databases. I mean, the original Cassandra comes from there. HBase heavily influenced from there. But now I'm starting to see different people have different takes. And that's starting to spawn off new projects. Right. You mentioned some of the kind of new SQL type things, whether it's Cockroach or Yugabyte. And those were designed a little bit differently, but they take components of Postgres, for instance, and incorporate it into their product. We had a talk from Uber where Uber did their own document data store, at Percona Live. We've heard from the folks over at PlanetScale about Vitess, which was built to handle YouTube scale, but it's built around MySQL. So what's your take on like these databases that are starting to be evolved or bolted on to kind of meet this new scalable workload? Where do you see those going?
Well, I'm not deeply familiar with those. Perhaps you might have more experience with them, but in the very large organizations, you've got the strength of expertise where you can say, Postgres is almost okay for us, but we need this one more thing. Or we think, we think we can get some competitive advantage by having a unique database, one that's no one else has got that has some unique features. And you've got, PhDs and, super developers, and you can give that a shot. And developers are always, really keen to build their own databases because there's always something wrong with the one they're using. So you've got that, if you let developers do it, they'll do it. And a lot of times these projects don't come to much. You might remember Project Voldemort from LinkedIn.
I remember
Jay
Voldemort,
Krebs, yep. I think, was the inventor of that, and that didn't sort of like get outside of LinkedIn. But then he went and did Kafka, and that did, get out of LinkedIn. So these innovations out of these, really massive companies, sometimes they just become a sort of like a flash in the pan inside that company. Sometimes they become, a significant part of that company's competitive advantage, and sometimes they break out and become part of the open source ecosystem, and we all get to benefit from it. But for the vast majority of us, we should not be thinking about, modifying an existing database. We should be thinking, we should have the choice. All the choice you talked about at the beginning of this session, gives us a lot of things to choose between, and hopefully, we can find something that's good enough and get on with the job of building an application. Because when you're building a database, you're solving your own problem. You're not solving your customer's problem. So you should be, choosing the best database, making a good decision there, spending time tuning it. But if you're building a database, then you're probably not building, user functionality that's really going to make a difference.
Okay, and at ProvenDB, you've got your own kind of unique database there, which is a blockchain database, right?
Yes, yeah. So we, our aim is to sort of be at the intersection of database technology and blockchain technology. So, now I just can't help going into pitch mode here. So just forgive me as I do it.
That's okay.
Go into pitch mode and all that. But one of the things that I noticed when I was working with databases, for most of my professional life, is that we didn't really have any way of guaranteeing the contents of the database. I knew as a DBA that I could just manipulate the database and leave no trace. And, beyond that, you could get down to the database files and change bits and bytes in there, or go straight to the disk. And so when the database says, this row or this document was inserted on this timestamp, there was really no particularly good reason to believe it. You're just really trusting the developer or the DBA that they hadn't been corrupted or that no hacker had got in and changed that. And then blockchain gave us the ability for the first time to have immutable records where we could be sure that no one had manipulated them since they'd been, added. But there was no way you could build a sensible application on top of a blockchain platform. They just didn't have the storage capability, no schema, bad performance, bad economics. So what we've done at ProvenDB is we've added to MongoDB as our base platform a sort of an anchoring system that takes the data in MongoDB and creates digital signatures and anchors them to the blockchain transparently to you. You don't have to do anything for this to happen. And then if you want to assert that, like to an auditor or to some other regulator or to a customer that, no, this is the record, this is the proof of identity document, this is your will, this is the accounting transaction, these are the legal signatures. You can prove without any doubt whatsoever that the dates of these documents are correct. And that they haven't been tampered with. So that's just kind of the short elevator pitch for.
So it's really certifying that those documents are legit. That's really what it is. Mm-hmm. It's a signature, that can guarantee and it's important because right now, so many people have so many needs for compliance issues and to make sure that their data can match what government regulators might want. It's a crazy environment.
And as a society, we are being bombarded with fake and fabricated news and information. We need to have a way that we can trust the information in our world because when we use paper and other sort of like physical media, we could look at that paper and we could forensically check it and we could sort of, even carbon date it. There's lots of things we could do to say, okay, this is real. This is a real piece of information. Now, we can copy and manipulate digital information so easily that we're all at risk for, well, as you know, one of the things that's coming up is you'll be able to take this video and make me say whatever you want with a piece of software that you can just download.
With deep fakes and things like that.
And that's the only protection, I guess, that we can have out of that is that as this video is uploaded, we create a cryptographic signature of it and anchor it to a blockchain so that at least I can say, no, this is the original. I never said that about your mother, Matt. It's a lie, and so that's kind of our mission there. So that's I've always wanted to sort of do something unique. I've followed a lot of databases and I've been a commentator and a practitioner, and it's been great to sort of have a shot at sort of like adding something worthwhile to the database ecosystem.
Very cool. Very cool. Well, Guy, thank you for sitting down and chatting with me. As I mentioned, Guy has a couple books out. Head on over to Amazon. You can check them out. The MongoDB performance tuning book, and shortly a book on CockroachDB, which will be very interesting to read. You can also check out Guy's Percona live sessions, which are up on YouTube as we speak. Guy, thanks for hanging out with me for a little bit.
It's been an absolute pleasure. And I should just quickly shout out, Percona Live was the best online conference I've attended since the pandemic made online conferences such a big thing. But by far, best, most well organized, best content, and the attendees were really engaged. It was just great.
We love to hear that. We're glad that you had a good experience there. Obviously it's hard when it's remote, but we're glad we got this right.
Excellent. Good job. Okay. Thanks a lot, Matt.
All right. Thanks a bunch, Guy. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.